All right, so I just want to explain what I'm working on. I'm just trying out, just doing some streaming of what I'm working on, just to see if it can help anyone out there. So, just a quick overview. I'm a software developer, and I'm working on an AI project. Basically, the idea of the project is fairly simple. You just take a picture of your house, and I want to make an app. So you can take a picture of your house and then just repaint parts of the house so that a person can get an idea of what their house will look like in different paint colors. I'm calling it House Paint Visualizer. It's fairly simple. I've been working on it for a bit now, maybe 6 months, almost a year actually. And it's a little bit harder than I thought. But just to give a quick overview, basically, yeah, the idea is pretty simple. And the reason I'm just trying out streaming, kind of my process on how I'm approaching this problem. And there's a lot of like AI content creators out there, and I feel like I'm sure there's a lot of good stuff, but I think a lot of it is kind of introductory level. And what I kind of want to show and maybe help an audience with is just kind of super practical problem solving. Like, how am I thinking about problems? What resources I'm using and stuff. And frankly, I have a lot to learn too. So part of this is maybe I can get some feedback and get additional resources and insights on how to do stuff and how to improve my development process. But one of my thinkings around making this content, I call it content. I hate to even call it that, or basically streaming what I'm doing is uh, is because there's so many developers that are kind of learning AI, and it's like a new arena that I think developers, and when I say developers, I mean that uh, kind of the way I think about that is actually a web developer. I started web developing like 15 years ago, uh, mostly in like PHP and the LAMP stack. But now these days, there's so much AI stuff, and it really interests me. And I just end up using it for various projects I'm working on. So I'm just like at the point where I'm kind of doubling down on it. I'm like, all right, let's just get good at it. And so I learned Python, and there's ChatGPT and stuff that makes it so easy to help develop now. And also, I'm basically an indie developer. I just work for myself, so I figured I can. So I'll just try it out. What the heck? So if you're kind of a developer who already knows the basics of AI and machine learning and stuff, I think this could be helpful just to see the workflow. And honestly, I probably am not going to talk that much when I'm working just because it's distracting. Um, so I would recommend a lot of fast forwarding. I'll give a brief overview of like what I'm working on at the beginning of the video, and uh, and maybe through throughout at some points, but for the most part, it'll just be me working. So um, I guess maybe I'll try to explain what I'm doing every once in a while, and probably at the end of the video just to see how things went. Um, so I'll go ahead and start talking about what I'm working on. So again, it's a house paint visualizer. Just to give you like maybe I can pull up what I'm working on here. So I have like tons of samples, but the basic idea is you have a picture of a house and I want to recolor it. And you can see I'm trying to recolor the blinds or the shutters of a house. I think it's the shutters of the house, and it's not working well. You can't see any difference, but it just depends on the test that I'm doing. So let me pull up a test that uh, maybe is okay. It's hard to know what you can see. I've been working on this for a bit. It's not very good, but again, let me pull up let's see if I can find a better one. So we'll do. That's really not good. Really not good. Try different tests. Uh, So yeah, I'm trying to recolor parts of a house. This is bad, but I guess you can still maybe get an idea of what's attempting to be done. So Here you can see I'm still working on the shutters. So basically the idea is I want to recolor the siding of the house, the brick of the house, the shutters of the house, and the doors. And once I get that working, and by recolor I really mean repaint, which can be a different thing because I want to give the user, the person who wants to repaint their house, a really good sense of what their house is going to look like in a different paint color. And there's a lot of challenges to this because color is kind of weird. And when you take a picture, color can, like a blue can look maybe like purple, or a purple can look more blue depending on the lighting and stuff. So figuring out how to recolor is basically a kind of a project of its own. And then also figuring out how to actually get the masks of a house part is kind of a project of its own. And that's what I'm focused on, at least today in this video. You can see, let me see if I can show the mask. So here's the masks of the shutters. If you can see this, is basically just the part of the shutter that I'm trying to capture. And um, it's doing an okay job of getting the shutters. And the images size that I'm working here is 256 by 256, which is really too small. The end product I want to be 1028 by 1028, so it really pops for the person using it, and they can get a great feel of what their house would look like. You can see these the masks here are okay. I basically fine-tuned segment anything, which is Facebook's uh, model for image segmentation, but it's not perfect. It's okay. There's problems with segment anything, and today I'm going to be working on trying to create masks of shutters better than these. Um, so I use Label Studio to like label a bunch of images of houses that I got on the web. Uh, um, uh, and basically, I just went through and like just drew rectangle, drew things over the shutters. So I've been working on this for a year, and various aspects of this for a year. There's more than just this. Um, and this is just one test, but you can see the system's trying to recolor this to black, to white, to red, um, to various colors. And there's a lot of problems. So I've used a GAN to train this. I've done hundreds of different tests with like various architectures and different systems. And so I have a feel for kind of what works okay and what doesn't, and the problems, but still not the best feel. And I look at a lot of different papers. I've read a lot of different papers to see what works well. And kind of where I'm at is GANs work okay. If you don't know what a GAN is, you could just look it up. But it's really hard to control and improve, and I don't like that. So part of my thinking is I really like the process that OpenAI took, which is kind of this. I'm not sure if I can make it work, but I like the idea of really being able to control your your model and continually train it, and uh, kind of like uh, I guess you could say fine tune it, but really like make it do what you want. And that is not at all. That's very challenging. Um, I know I'm talking a little bit abstract, but I'll get into more details. So what I'm working on today is I'm going to try to take I'll show you. Um, let me see. Um, all combined images. So now I'm starting really simple. Let me just crank this up. I'm just having a system that creates a rectangular shape, and my model. So on the left here, this is, and I'm actually working with 1024 by 1024 images. On the left here, this is, maybe just give it a second. This will make more sense. There you go. So on the left here, this is the actual image, which is just a black image um, with one rectangle in it. And I'm just trying to like basically start as simple as possible now. I don't always, I've done a lot more work, but I'm trying to start as simple as possible and just have the model recreate a black image with the white rectangle. This is just to ensure that my model actually has the ability to copy the image exactly, because it doesn't always. And segment anything out of the box won't be able to do this, interestingly enough. Like if you try to train it to just just copy this image, the corners will be all rounded. And there'll be like holes in the middle and stuff. It's kind of weird, but I think it makes sense once you understand the encoder decoder architecture. So I'm basically I'm trying to rework the segment anything uh, model to it's a VIT model. It's a vision uh, something transformer, but it's basically the transformer architecture. Um, so I'm trying to rework it to be able to ensure that it has the ability to do what I want. Um, and so today, what I'm going to try and do is, I guess, my general approach is I'm going to train it to try to reproduce the masks on a bunch of images that I already masked. So I have like 100 pictures of houses, and I masked the shutters on those houses. But the problem is it creates masks that are okay. So that'll be kind of the first step. It'll create masks that are okay. Then what I want it to do is so when I say okay, the masks are going to have holes in them. They're going to have rounded corners. They're not going to be perfect rectangles. Shutters are generally perfect rectangles, so that's what I want. So what I'm going to do with the OK masks is I'm going to try to, um, I'll probably try to, yeah, what I'll try to do is kind of have a GAN setup where I say, okay, this is, I'll train I'll train it in a GAN setup. So I'll say, I'll create a model that basically looks at a mask that I want I'll call it the segment anything model to produce, and a mask that I don't want it to produce. So it'll basically be a score, 0 or 1. And then I'll train a model against that to produce masks that look like what I want. So it's not as simple as like an MSE loss on the mask. It's more like this mask is what I want, what Taylor wants. And so in order to do that, I need to have what do you call a GAN discriminator? Yeah. So it's called I'll have a discriminator. It'll the setup might not be exactly like a GAN, but it'll be the same idea where you train something that says, okay, this is good or bad, and then make it as good as possible. So I'm gonna start by just taking the segment anything VIT and recoding that from scratch. And the reason I'm recoding that from scratch is because I want to understand um, how it's working and why it's not doing what I want it to do. Um, and also just cleaning it up and making sure I understand it so it fits in my model. You might be like, oh, that's a waste of time, but I think it won't take me that long uh, to actually just basically recode it, and it'll also help me get an understanding if of the capacity of the model and if anything else is going wrong. Um, so this is working pretty well to recreate these masks, you can see, and I think it'll from before I saw that it's working okay. Um, and it's okay. You can still see this mask is not that, it's like it has rounded corners a little bit. The background is not all the way black, but I think it'll get there. On smaller rectangles, it does some funkiness. Um, so one option, I think I might combine like a traditional unit with like a traditional CNN unit with the transformer architecture. Um, because I've seen there's a UVC GAN uh, does this, and I've worked with that, and it actually seems to work pretty well. I'm not sure if they did that in the optimal way though. Um, I think there's some benefits. I think the CNNs, the UNet CNNs, are pretty good at certain things that the transformers aren't. Specifically, I suspect that they would do a better job. Actually, I kind of know that they'll do a better job of like getting these corners to be pointed, and also things like getting the colors right and little things like that. Especially if you have the UNet architecture. Um, and it seems to me like the transformers are better at like getting like form. So like if you have a house, it'll kind of be able to recognize what a house is and like the components of the house and memorize that better. But when you're reconstructing the whole thing, I don't think a transformer is going to do that good of a job of like getting the right colors on the shutter or getting the edges just right on the shutter. It has like a good idea of the general form, but not like rebuilding the form. The CNN seem to do a little bit better on like the texture and the stuff, which is I care a lot about that. Um, and I've tried different architectures too. But so I'm just curious. What I'm going to do, actually, real quick, I just want to test this before I start rebuilding my own. Is I want to see. I'm going to build a discriminator, a GAN architecture where the GAN it actually tries to make circles instead of rectangles, and I just want to see how the uh, kind of how the adversarial. Basically, in a GAN setup, you generally have an adversarial loss, which is just means it's trying to trick the discriminator, or yeah, that's the way to phrase it. Um, so I want to see if uh, right now this is just a mean absolute error. So it's literally just trying to recreate this box. But I want to add an adversarial loss to that says, okay, we also want to trick the discriminator. And this I'm going to train a discriminator that says circles are good and rectangles are bad, just to get a feel for uh, if the GAN setup is working, one, and also like the GAN loss versus the adversarial GAN loss versus the mean absolute error loss, and how combining those two things are working. Um, is it meeting in the middle? I just want to see how that's interacting. Uh, I think it's important for me to understand that. So yeah, I'll do that real quick. So just a fun fact I have out in my uh, basement, basically down here, I've got my own machine learning rig that's running a GeForce 4090, and it's jangly, like it breaks every once in a while. I think it's something to do with the CPU. Now I had a 4080, and I thought it was something with my GPU, but I just spent like 2,500 bucks on a 4090, and it's still not working well. I'll train for like 30 minutes and break. I don't know what's going on. So if I'm training things overnight, I use AWS, but just for testing, I'm using my local rig here. All right, so here I'm training uh, this autoencoder. Um, and I have this disk model, and uh, this is what we're going to train to recognize squares and circles. Um, I think, yeah, it looks big enough for people to see. All right, here's my, what do you call it, a distinguisher? No, what is it called? I literally always forget the discriminator. Okay, this is my discriminator. So what we're going to do is we're going to create a function that creates just a circular looking just creates a circular mask. And then we're going to train, and this is generate random box mask. And we'll use ChatGPT to do this. Makes ChatGPT so amazing. Okay, and while that's doing that, come back down here. Okay, and we want this to be the mask circle. So this is going to be like, we're going to train the discriminator to and let's just do a mean square on this. I'm actually trying to think how best to train this discriminator. There's there's traditional setups and there's other ways to do things, obviously. I could make the discriminator try to detect when the generators outputs an image, and that's the standard approach. But I'm actually just going to make this really simple. I'm just going to say it's not going to be about being. It's not going to be about putting 0 for the generator produce. It's just going to be the discriminator just says it's going to say rectangles are bad, um, circles are good, because I just want to get a feel for how it's working. All right, here's our ChatGPT's failing me. It's taking a second there, so we'll get that function done. Uh, all right, and so what we'll do is we'll say, so that's the mass prediction. So we want to say, we'll call it, we'll just call this dis prediction. This is the dis model's prediction of the masks. And what we want to do is, yeah, so we want to, yeah, that's right. So we want to pull this, the adversary, we want to pull the, we're going to have 2 losses now. Get rid of all this. Let's just see that. Uh, I want to see what the adversarial loss is doing. Um, so basically, I have two losses. I have a mean absolute error loss that simply makes the mask prediction look like the real rectangular masks, like this rectangular masks. And then I also have this adversarial loss, which is going to hopefully pull it'll actually work against the absolute error loss to make the mask look like a circle. Uh, oh my gosh, ChatGPT's sucking. So the one thing we need to do is we have loss, so we need to actually say, well, it's just the reconstruct loss plus the adversarial loss, and then we'll step through it. And in this check accuracy, I just want to make sure that this I just want to make sure that mass circle is doing what I want it to do. ChatGPT, Jesus. All right, let's try this again. ChatGPT isn't. We'll have to use Bard here in a second. We're going to Bard. We've got to do it. ChatGPT sucks. Use Bard. Here we go. Taking too many tries. All right, here's Bard solution. Let's go with ChatGPT. It tends to be better. All right. Generate random box mask, generate random circle mask. Oh, sweet. Okay. We'll see how that works. My disk model is, I gotta check whatever the disk is here. Tays disk. So this is a patch GAN, which should be fine. Looks like I'm returning the probabilities of being real and also like the last layer, just the raw features. So I just needed a couple things. Okay, let's just see what's happening when we do this. Okay, let's make sure it's producing circles. Test circle. It seems to be all right. So it's making circles. So it is weird because it's like telling it to make circles, and it's also, it's the loss is weird. Not working very well. I'll try it with just the. We'll just let it train for a second here, but let me see what losses we're printing here. This is actually the reconstruct loss, the first one. It's getting worse at reconstructing. And adversarial losses all over the place. And this is also the reconstruct loss. Yay, yay, yay. It's not doing a good job of figuring that out. I'm gonna let that run for a second and use the restroom. Heart rate okay? Let's see what's happening. Nothing good. All right, it's good to know. Let me see. Just gotta turn this way up. see how good. See how good this model is doing at learning circles versus rectangles. Surprisingly hard to train, like two models. I think we're back. Should both be going down. Feels like it's the easiest thing ever to tell if it's a circle or a square. I just this should be going down better. I understand how you can't tell the difference between a circle and a square. It doesn't look like it's going down. This type of thing's frustrating to me. It just seems to me like this disk model should so easily be able to tell the difference. Let me just think. Let me just do this. I'm just going to pause all this. Pause all this. Just focus on training this. I just make it go much faster. Maybe that is going on where batch size is too low. Um, I wonder. so it learned that. Yeah, it's got it. Shouldn't be that hard to learn. And now our model seems to be figuring out square versus circle. So I wonder, I think, let me just see. There's, I guess, one generator, this optimizer, zero grad mass. Okay, so just think, we'll leave that, we'll leave that. The same, no, it's not the same. It's a change, it's gonna be 128, 28 is gonna be 256. By 256. I'm just trying it with a smaller image now. Okay. Not sure why. Now it seems to be the discriminator seems to be learning. Okay, now. This looks like the adversarial loss. It looks very small. Okay, that's kind of annoying. So it's somehow tricking the, figured out how to trick the discriminator. So I'll need to add another, oh, it just produces black. Okay. Okay. Um, kind of my hope here, what I want to see is this meeting in the middle. So that would make me happy, because then I understand what's going on. But what I want this to look like is a rounded, like a rectangle, but rounded. That would, I would feel like, okay, it's doing an okay job of getting a mean square error, and it's doing an okay job of tricking the discriminator that wants a round rectangle. It would make me happy. Make me happy. Okay. Maybe it's doing that a little bit. It's trying to round a little bit. Maybe a little bit. That's too low, that error. Oh, like this discriminator is not. We need to add a traditional discriminator loss. So I'm going to add another one. This is the fake prediction on. Um, so this will make it harder for the generator to fool the discriminator. Like this, I don't know what the hell that is. Makes no sense. I'm not calling this gem model anyway. Uh, Generator model doesn't take in the full image. Just a 3-channel image. All right, so now here's the adversarial loss. It's higher. GANs are so hard to train, so annoying. And you can see that discriminator is doing a very good job of going low, lowering its error. It's having an easy time telling what's real and fake. And the discriminator is not doing a good job of producing circles. And it's producing like the weirdest artifacts. Crazy. It's completely failing. Oh, okay. Stupid discriminator. Now it's turning. I don't know what it's trying to do. Stupid generator. That's it. Adversarial loss is just completely gone. What's the mean square error loss? Or the mean absolute error? This is the reconstruct loss. I don't understand. Yeah, it just boom, died, collapsed. Just giving up. Just creating black. I don't know what could be encouraging the generator to create a black image. So weird. I'm going to do this. I'm going to yeah, it's still just creating a black. Well, it's not quite black. It's creating this little like cloud looking thing. It's the same for everything. Oh, now it's just creating a white. all white. Gosh, this it's really all over the place. Now we get this little so crazy. To me, it seems like such a simple solution. Just create like a rounded rectangle. It's this like little cloud thing. Now it's creating this is all over the place. And it doesn't seem to care at all about the image that it's taking in. It seems so easy to solve. Like, I don't know. Let me try this. I'm going to try to put a gradient penalty on the discriminator. Have a nice let's see. Yeah, UVC GAN 2 has a nice gradient penalty function that I'm using. So this gradient penalty, like gradient penalty, I've never had any success with this gradient penalty, to be honest. Um, so the way this is actually Actually, how that works. Let's see where we're at on this too. Oh, no, maybe something was happening. Hmm. If it helps anything. Okay. Well, I would call that better or worse. Okay. Well, maybe. Does seem to be slightly less crazy, maybe. Kind of like instead of rounding off the edges, it's kind of like, or maybe it's okay. Like semi, not terrible, maybe. Create a circle. Create a circle. Oops, now we're just all black. Ay, ay, ay. Lapse. Do just adversarial loss. See what happens. This damn thing to create some circles. Make me a circle. Make me a circle. Not this spot. You know what? Maybe it's the generator model. Like make a damn circle, Jesus. This thing can't figure out how to make a circle. All it has to do is figure out how to make a circle. My generator, holy cow, it's so terrible. It doesn't even have the losses, it's just adversarial loss. I'll change the window size so that the model can attend to itself fully. And I think break not working very well anyways. This EIT model has windows, so it's a transformer. So instead of basically attending to every patch, it will attend to only the patches in the same window, but I just disabled that, so now it's attending to everything. So we'll see if that makes a difference. I think part of the problem is just like, it's so annoying to me that it can't create a circle. Maybe circle, I think. I'm gonna try a different generator architecture. So this is just a unit, um, basically a CNN unit. Pretty simple architecture. Um, okay, it's maybe kind of making circles now. Now the only loss is the adversarial loss too. So it's like it doesn't sound to balance anything. Let's see what ChatGPT thinks. Let's see. This is kind of a broad question, but we'll just see. 'Cause there's just circles. There's another thing possible, but make sure these circles aren't too small. worried that it's creating too small circles so the generator, so it's like just realizes we can create a black image. This circle sucks. Super lazy. I'm just gonna copy the whole thing. Oops. All right. Awful, awful, awful. Let's see. If that looks right. Mama. Way different results. Oh, that is way better. Wow. I don't know. Oh, what is going on? Now the test circles are pretty big. Oh, my golly. It is all over the place. It's just getting worse and worse. This is why GANs are so annoying to work with. I just think that. Let me try. Actually, might figure out how to do a circle. The thing is this discriminator is getting really good at telling what's real and not real. So strange. Let me just try. Honestly, not sure what happened if I just kept letting this train, but it's sucking. It's taking forever. If something takes too long, I just can't do it. I don't know if it's going to start working or not. Probably it won't. And even if it does start working, like how long is it going to take to train? But now I'm just trying to train it. All it has to do is make a circle. Make a circle, make a circle, make a circle, make a circle. I'm going to try to use a different discriminator. This is a dropout. I'm not sure I want. I'm going to take it out. So we have a sigmoid, FC2. Okay. Oops. We're going to use a different discriminator. I also figured out how to trick it, but this is super low, so it's it's no good. Yeah, it just doesn't know what to do with that. Unfortunately, I just think you need. know about that gradient penalty. It never seems to help anything. Oh, let's see. This disk is returning. Let's just do this. We're using it. So we're moving away from a patch GAN. Backwards. So crazy. Let that run for a second. Deck. Okay. Hmm. Yeah. I think we might be getting there. So before I was using a patch disc patch discriminator. Now this to me seems to be doing a better job. What I would expect to happen here is it now just creates a circle of the average size, probably in the center or something like that. Now I don't know what it's doing. Let's see. Let's check this. It's so crazy. All over the place. I'm just going to do a sanity check here. All right, so this is like the easiest thing for ever now. Now I'm actually passing it the circle. All it has to do is make the circle. Okay. I think something's wrong with my GAN setup. It's painful. Literally all it has to do is make the circle. Like spell it out. It's got to darken. Could not be easier. It's getting it. It's taking a while to get it. It's like adding shading in. I'm literally passing the generator this image. So all it has to do is recreate that image, but it's back propagating through the discriminator. And I'm giving the discriminator what it's creating in this regular image. It just feels like it should so instantly be able to get it right. So so this is about the same. So the generator is like in the ballpark of the discriminator now. Just like isn't good enough. If I turn the learning right down, maybe remove that. I'm gonna try removing this gradient penalty. terrible. It's like kind of working, but with that gradient penalty. Seems to be worse, to be honest. Oh, no, no, no. Maybe fake loss too. Looks pretty similar to what was happening last time. The smiley face? I don't know if it's better or worse, but the gradient penalty. Maybe worse. Huh? Seems a little bit bad. No, it seems the same. The gradient penalty's not doing anything. Let me try another. This drives me nuts. See, I think what's happening is it's just like a little bit too. It just needs a little bit of direction. I just feel like without like a little bit of direction, it's so tricky to look up. Problem is like once you can point it in the right direction, what do you need that adversarial thing for? A flip here. working kind of now. It just all falls apart. there's some concepts I didn't know about here. Well, namely, just by two Chinese scientists. That's interesting. It's a nice little technique. This guy's a good writer. I mean, he's not a good writer. He's good at machine learning, so he's able to write about it. But this is a handy little trick. So instead of using this mean square error directly, I can set like a little threshold so it just has to stay kind of close to the to the mask circle, to the original circle, which I like. That's cool. It looks like he just does it by max. So you either take, oh, okay, so there's a threshold. So as long as it's not too bad. Oh, and this should probably be, I'll do MSC instead of, okay. But before I even do that, I think, well, so you're taking like this threshold of 10%. So we just gotta stay within 10%. Oops. This is cool. Um, I like that. The type of thing where it's just like a little, where did that red article go? It's a handy thing. And also, oops, I'm also a little confused about this. Oops. And for now, I really like this idea here. You're basically just like keeping it close, but you can do what you want. You know, that's what I need. I should have thought of it on my own. Oh, come on, ChatGPT, sucking. So I was maybe a little confused about Westerton loss. Honestly, I thought it was just adding the gradient penalty. This is like a real article. Most of the stuff on the internet is like not, I don't know how to phrase it, but it's like not information. It's something else. It's like summarization of stupid nonsense. Oh, I might just use that gradient penalty. But the Westergen loss is just a torch mean. So it's, let me see. So X real is the ones, negative. I'm a little confused on that, to be honest with you. Just pulling it. First of all, let's see how this is working. Still the, yeah, it blew up. The generator is not improving relative to the discriminator. So let's, what is the fake loss? It's even more simple. Real loss instead of fake loss. It's just the, it's right, the fake prediction. Fake loss 2. It's just the torch dot mean. And then when we trick it, I think it's okay to multiply by, I'm a little concerned about having that. I'm honestly not sure. You know what, let's just take out that. Make it easy. And when we train the, we just maximize it. So here it is. So now we have the, I think we already have that somewhere. Even else, it's, yeah, I'll pop it in there. Let's get that right. Yeah, I just syntax a little off here. Let's see. I'm not sure I have that quite right. I need to just make sure that's right. Let me, what is that? Max. All right. I'll just do that gradient penalty. See how that works. Oh, why it's not. Fix my spelling. I'm worried. Whenever you have to ask ChatGPT twice, it's not good. Usually, it's not going to get it. Let's see. Let's something else here. All right, so now we have a gradient penalty. Maybe the reason the gradient penalties weren't helping before is because I wasn't using the Wasser GAN loss or whatever. Let me see. Yeah. Jesus, it's annoying. All I needed. All the time. Just show me that one thing. I just have to George Duck tensor. Oh. get a change there. Just trying to fix my spelling. I spelled it wrong. Keep it wrong. Let me just try to understand this. So it's loss reconstruction. It's always going to be the maximum. If it goes under 0.1, it doesn't matter. Just don't go over it. Okay, I guess that's fine. So this loss is never going to be, the loss reconstruct is never going to be under 0.1. 0.1 is as good as it can go. It's as good as what we care about. It's like, okay. Oh, I like that idea. So handy. The reason I like it so much is because it seems it's like you can constrain the model. Because with a normal GAN, like I feel like you don't want the generator to just be able to do anything, because then it starts doing crazy stuff to trick the discriminator, and the discriminator starts doing crazy stuff to. It's just like way too much. But if you constrain it, then it's like okay, we can only do so much here. So I really like that technique, which I hadn't really been thinking about before. Now we're trying to get it to draw a circle with inside the circle. So I'm gonna go get some lunch, go for a bike ride. Um, but just to summarize, what I've been trying to do is I'm trying to make sure that the discriminator and the generator are working well together in a super simple context. In this way, I'm using two losses right now, basically a loss, just a mean square error to generate this, but then also I'm trying to generate um, I'm trying to train a discriminator to discriminate between just a regular circle and then a circle with another circle within it that looks like that. And so the adversarial loss should encourage the generator model to produce like that target looking thing rather than just a circle. It's like, to me, it's like the most basic, simple thing to do. And the mean square error loss I'm using now provides flexibility. So it has to be close to this circle, but doesn't have, just kind of constrains it to be close to that circle. Um, I'm gonna let this run for a while. I honestly don't know what's going on here, but I've tried using basically initially I was using a VIT model as a generator and a patch cam as a discriminator. But to simplify things, I'm just using I changed it to just use a UNet as the generator, and then just like basically a more simple discriminator. Um, and then I found this pretty good Reddit post on this guy giving some tips on GANs. Uh, Real practical tips. I've read a lot of papers and stuff. There's all sorts of fanciness, but the truth is, like, so much of the papers that I read, it's like people trying to either do too much or it's just like it's like not rules of thumb type papers, and sometimes they'll just eke out like a very small advantage through some crazy technique. A lot of the times in the papers, I think it's kind of like it's a derivative techniques, and so it's like a 50-page paper just to get some technique that probably won't work or like is only applicable in a very weird context. So I'm kind of looking for like just generic, what's the best way to do it type things. Like, what are the rules of thumb that work? I was using just mean square error loss for the discriminator and the adversarial loss. And it's not working well. So I'm trying to use this the Wasserstein loss, which seems super simple, but it looks like it also requires a gradient penalty. Um, Maybe I could try spectral norm. I've tried a lot of this stuff before, honestly, and I feel like it doesn't. It To be blunt, I feel like something else more found like fundamentals going on. So when I come back later, I'm going to try to look into. I just need to understand like the what's happening to the gradients better. And it looks like this guy has a process for doing that. Uh, let's see. Let me see what he says. So finally, gradient. I always use Wasserstein loss. It's faster than traditional GAN. I don't know what traditional GAN loss they use there, but so always use Wasserstein loss. You can weight clip, you can use spectral normalization or gradient penalty. He likes gradient penalty. I've never heard of this caming and initialization, but I don't think it's too relevant. So this is what I feel like I need to get a good value to set the L2 regularization to monitor how much the weights are diverging. I don't know what he means by weights are diverging. Sample. Hmm. Hmm. That's kind of complicated. Hmm. Hmm. This is so weird. It's like flipping. All right. Well, I got some more work to do. I'm still pretty confused on why this isn't working. I've just got to set up some simple GAN things and get it working well. I'm just surprised how hard it is to get the generator to trick the discriminator. It just seems like when you back propagate through the discriminator, it should like always work well, but it just I almost feel like I'm doing something like just something's wrong with my code. Like, but all right, well, I'll come back later. It's not making much great progress, but um, that'll be it for now.